Lesson 48 is about polynomials, and that word polynomial is just a special name for a certain type of term, and it has this form right here, ax to the n, where a can be any real number, and n, that's like the exponent, it has to be an integer. Remember, integers, those are like whole numbers. They can be positive, 0, or negative. So some examples of polynomials would be like this, even if it's a negative, it just has to be a real number. It can be a decimal number. A can be a decimal number. And even this is a polynomial. It's just that n is 0 in that case, because we could write that 3x to the 0, right? Anything to the power of 0 is 1. So just a number by itself, that can also be considered a polynomial. So to be called a polynomial, it has to have that form ax to the n. A is a real number, n is an integer. All those polynomials I've drawn there, those are all one-term polynomials, or monomials, they're called. Now a binomial, that would have it would be two polynomials together, like this, would be considered a binomial. And a trinomial would be something like that. Now all of those examples that I have there, those are all polynomials in one unknown. They all just have like an x for a variable. They just have one variable that's the same in each of them. Now a polynomial in more than one unknown, that would have like ax to the n, y to the m, z to the p, and so on. It'll have more than one variable in it, but the same rules apply to the exponents. Those can only be integer exponents. A is still a coefficient that's a real number. So just keep in mind here, polynomials, all those are is just a special name for a type of algebraic expression. Now when you have a polynomial, like this one I've just written, I'll underline it in blue so you can kind of see where I'm at. We consider the degree of a polynomial expression like that to be the highest number of exponents in a term. So like x cubed, the highest exponent there would be a 3. Then we have a to the 1, b to the 1, c to the 1. So that you would count up those exponents to 3. So that particular polynomial expression, we would consider that to be a third degree polynomial expression. And then in the one I've drawn below that, we have an a squared, b squared, c squared in there. So that would be considered like a 6th degree polynomial. So that term there has 6 degrees to it. That's the highest degree term within that expression. Now that's something we won't be concerned with a whole lot, is the degree of a polynomial, especially ones that have more than one unknown in them. Usually we'll just be working with expressions like this that maybe have a 2nd degree polynomial. And just like I've written that one, 3x squared plus x minus 5, usually the polynomials, the powers are written in descending order. Like I've written the x squared first, then the second one is x to the 1, right? And then the last one, if we wanted to put it on there, it's x to the 0. 2, 1, 0. So that's usually how polynomials are written. That's just kind of a standard accepted form for writing a polynomial expression. You write them in descending order of the power. Now look at practice problem A, and that one what I want you to do is add those two polynomial expressions together. And you probably already realize that these are just like adding like terms, because they look like a lot of the algebraic expressions that you've been adding together already. And so what you do, like on the left we have that negative to work with, and so we need to just remember that we need to multiply each term on the inside by negative. We don't have to rewrite the whole thing. I mean, you can if you want to, but I'm not going to do that here. And then on the right, just kind of ignore those parentheses, because you really don't have to be concerned with those since there's no negative sign in front of them. So let's just go ahead and add like terms together. We have a negative 3x to the 4th on the left. We need to add that to the positive 2x to the 4th. So we'd end up with a negative x to the 4th. And then we have a negative x to the 3rd to add to a negative 3x to the 3rd. So that would give us a negative 4x to the third. And then we have a negative 2x squared. There's no x squared term in the other polynomial, so we just leave it negative 2x squared. And then we have a negative x. There's no x term in the other polynomial, so it's just negative x. And then we have a negative 1 to add to a positive 11, so that would give us 10. And so there's our addition of like terms result. Let's do one more of these, and let's add these two polynomials together. And so first, why don't we go ahead and get rid of that negative sign on that second polynomial in front of that, and let's go ahead and do all the multiplications first. And that'll just help us eliminate a mistake. And so we'll have x to the fifth minus 2x to the fourth plus 7x cubed plus x squared minus 3x to the fourth plus x cubed plus 4x squared plus 7x minus 5. Okay, now let's look for like terms in here, and when we have it all written out like this, it can get a little bit confusing, so let's just go ahead and underline x to the fifth, and let's see if we see another fifth power, and I don't see any other ones, so it would just be x to the fifth, and then we have a 2x to the fourth, and then there's another one right here, a negative 3x to the fourth, so we have negative 2 and negative 3 is negative 5x to the fourth, and then we have a 7x to the third and an x to the third, so there and there. So let's add those together. That would be 8x to the third. Then we have an x squared and a 4x squared. That would be a 5x squared. And then minus 5 on the end. Well, actually, we still have that 7x, right? So we need to add that on. So we'll say plus 7x minus 5. So on these problems, it's just a matter of staying organized, keeping up with your exponents, and keeping up with your like terms. So one thing you could do is cross out your terms after you're done adding them together. Like cross out that x to the fifth, and then when you get done with the fourth terms, cross those out. Cross the thirds out, then the seconds, then your x to the 1, and then you're left with that negative 5. Like I said before, one of the important things in algebra is you're trying to figure out a way to solve these problems the most efficient way, and that means the way that will provide the least amount of mistakes, and especially the least chance for a mistake. You want to eliminate chances for an error. And usually that means you have to write stuff down a little bit more than you would like to. A lot of times you want to do stuff in your head, but there's a skill there. You want to have a balance between doing too much in your head and then also doing too much on paper. If you do too much on paper, then it just slows you down and it takes forever for you to do your math. So you want to try to develop a balance there. Okay, well that's all for lesson 48.